Good afternoon, ma'am. Ma'am, are you there? I can't hear you, ma'am. You are on mute. Good afternoon, ma'am.
Good afternoon, Ria.
Can't hear you, ma'am.
Only you.
Still can't hear you, ma'am.
Okay. Only one is present, right?
Oh, sorry, ma'am. My volume was low.
Okay, right.
Sorry.
So where is another people? I think you people are getting bored right now, right?
I don't know, ma'am. This from morning you're having class, no, ma'am. I was also
awesome.
doing the stuff in between classes. I had my breakfast also during the class. class.
So I think maybe in present in the morning 18 or 20 members, right?
Morning 22 were there, but half class mein people went away. So
Okay.
18 then now there was 17 when the class ended, na, the last class. 17.
Okay. So still
people should have come, but they are joining late only, ma'am.
Later, okay. So I'll wait for 5 minutes, okay?
Yes, okay. I was going to ask you some question regarding this. I forgot.
Yeah, tell me.
I forgot, ma'am, what I was going to ask you.
Okay, don't worry.
Yes, I'll recollect, then I'll ask, ma'am.
Okay, no problem. Okay.
Yes, ma'am. All these chapters are very interesting, ma'am.
Okay.
C8 is very nice, very easy to understand, and we can write the answers on our own also.
Yeah, you can write easily and generally, right?
Yes, ma'am.
Utna easy aita. Utna
yes, ma'am.
Easy aata, right?
Yes, ma'am. But then for the assignments, we have to write so much, ma'am. If the question is talk about C, we have to write about ABCD and then EFGHI also to complete 15 pages. Sir said to write minimum 12 to 15 for long
answer.
How many
pages? 15.
Yeah, 12 to 15 pages for long answer and 7 to 10 pages for short answer. So the answers are very direct. So we have to write the whole background story and future about them. Then only we'll complete so many.
Okay.
And we are drawing diagrams also.
Okay.
Yeah, complete so many pages.
Complete it at the time of practical examination.
Yes, ma'am.
No worries. And then also fasting also, yeah, Ramzan fasting.
Yes, ma'am. That's why I'm trying to complete it before Ramzan. That time we will not get so much time.
Okay.
That's why I'm trying to complete it earlier. Ma'am, we will have records also, no? For practicals. We have to do it in class only, no?
So that is not a must and should.
Oh, okay.
Only you can submit your assignments at the time of practical examination.
Exams. They will be just right after the practical classes, no, ma'am? Just like last time?
Yes, same as.
Okay, because last time when Vishnu sir had told us that both the batches will be there, then the exam will be taken place.
Yeah, but you can submit it in end of your exam, right?
Yes, ma'am.
3 or 4 o'clock, maybe, or 2.
We can't submit it during the practical classes, ma'am?
You can submit, but
it will be misplaced.
Yeah, that's why.
Okay.
That's why I doubted. Okay.
Yes, ma'am.
Dalia Das, Durgesh, 2 more people are there.
Yeah. Some few people will come, ma'am.
Good afternoon, Durgesh.
ఫీవర్ ఉంది మేడం కొంచెం.
అయ్యో ఫీవర్ వచ్చిందా? పడుకొని
మేడం యాక్చువల్లీ మా బాబుకి ఫీవర్ వచ్చింది మేడం ఫస్ట్. అక్కడ నుంచి నాకు
nowadays viral is going on, no ma'am?
Yeah,
that is the problem.
Everybody is falling ill.
9900 ఉంది మేడం. అంటే మైల్డ్ ఉంది.
Okay.
Yes, few people are getting only mild, like I also got very mild, but then my relatives got very high, 104, 103 temperature, and then cough and then cold.
జాగ్రత్త ఉండాలి మేడం.
అవును దుర్గేష్, నాకు అదే అనిపిస్తుంది.
చికెన్ కర్రీ తిందాం అనుకున్నా మేడం, ఇంకా ఆపరేషన్.
మరి హాస్పిటల్ తీసుకెళ్లారా బాబుని?
మేడం అదే లాస్ట్ వీక్ వచ్చింది మేడం ఆయనకు.
అచ్చా, ఓకే.
అయిపోయింది, మంచి సెట్ అయిపోయాడు, ఇంకా రాకొచ్చింది.
మార్నింగ్ నుంచి క్లాసులు వింటున్నారు కదా, కంటిన్యూ నేను తీసుకుందాం అనుకున్నా, వాసంతి మేడం సరేలే పోనీలే తీసుకోవాలని మళ్ళీ మీకు యూజర్ నేమ్ పాస్వర్డ్ చేంజ్ చేసి ఇచ్చాను.
Ma'am, can you talk in Hindi? Ma'am, can't understand.
It's okay, no problem. So continuously taking the class, people are getting bored, I think maybe.
Yes, ma'am. So, and it's not an interesting subject also, ma'am. Very technical, and methods are there. Treatment of water. That is why. If these kind of subjects are there, atmosphere and like yesterday carbon dioxide, it will be interesting to hear.
Yeah, these are general topics, right?
Yes, ma'am. Yes. Those are more technical, so it will take more
water
understanding.
Technologies. Like that. Okay.
So that's why it's little both.
Okay, no problem.
228, ma'am.
8, okay. 2 more.
Only 3 students have still come. Including me.
Okay, morning 18.
Morning, they were nice, ma'am.
Yeah.
But not like first year, ma'am. So many people used to come for offline also. At least 30 people used to come. Now nobody's coming. I don't know why.
Same, continuously year and year, same like this.
Last year also second year batch, few people used to come.
Every year.
Okay. But in practicals, people will come, no ma'am?
Yeah. So that is must and should, na? That's
Yeah. But it will be difficult for them to follow, ma'am, when they don't attend the classes, not online class also, not offline class also, then it will be difficult for them.
How people are writing in the examination, I don't know.
Yes, ma'am. I also wonder that only. Some people did not attend practical classes also, I guess, last year.
At least online classes, at least offline classes.
Yes, ma'am. Few people attend offline, online classes also, but they are not present in the class, ma'am. They are just online.
Yes. That is the main problem.
Yes, ma'am.
Okay.
You ask questions by people's name, nobody will answer.
So that is necessary, no? Necessary.
Yes, ma'am. Mostly Durgesh and I only answer.
Yeah. And also Dalia and Asha.
Dalia also. Dalia is always present in the
Only
class.
these 4 people.
Yes, ma'am. Dalia also does not miss any class, ma'am.
Yeah. Dalia, you, and Nishita.
Harshita, she did not attend today's class, ma'am, or last time's class also she did not attend. She has some work, I guess, ma'am.
Yeah, I know it.
So that's why she's not attending. Today, Bhargavi and Asha also attended. Last time they did not. Yesterday they did not attend.
Yes, I saw it, Bhargavi.
I missed a few classes because of training, madam.
Okay. From Kadapa nunchi two people are attend today. I think Jafar Baba, maybe 2 other people are attend.
Yes. He also answers to the question, ma'am, but then he types the answer. He does not tell vocally.
Who is?
Jafar Baba only.
Jafar Baba. Okay.
Last year he used to come, ma'am, regularly for offline class. This time he
Jafar Baba?
Ma'am.
Yeah, okay.
He came for most of the classes. This time, not even once he came, I guess. Only the first day for introduction, many students came.
Okay. I think they are in...
slowly, people are joining.
Works. Right.
We'll wait for 5 minutes, then you start, ma'am. It's already late.
Okay. Bhargavi Murugaya. Okay. Srilata.
Ma'am, you did not give the presentations yesterday. You did not send them.
I will post today. Yesterday 2 and today 1 or 2. Okay.
Okay, ma'am. No problem.
Bhargavi?
Yes, ma'am.
Juice boy చేస్తున్నావా?
Yes.
I like it. చాలా బాగుందమ్మా. జ్యూస్ బాగా గుర్తు చేసుకుంటాను నిన్ను.
In practicals also you make once and get Bhargavi.
Okay, thank you.
Yes.
Okay.
If it does not take much time, then only. Otherwise it's okay.
Oppo A5s. Oppo A5s with this person.
Ma'am, how many students are there in second year?
Total 105 or 115. 115.
That's it, ma'am. First year they were like 190 students.
But they are 10.
Only 8 came, ma'am.
Yeah.
Even online classes, 20 are also not coming, ma'am.
Yeah. That is.
Hardly 20 are coming and they are also leaving.
వాళ్ళు ఏదో వర్క్ లో ఉన్నారు భార్గవి. ఏదో టైం పాస్ ఉన్నప్పుడు వస్తున్నారు, టైం ఉన్నప్పుడు. నెక్స్ట్ వర్క్ ఉంటే లీవ్ ఫిట్ అయిపోతుంది.
If we listen to these classes, ma'am, it will be easy for us to read it again. Then we'll get it in our mind.
Some classes we can write also, ma'am.
Yes, we can write on our own because see, these topics are very familiar to us. So we can write on these topics.
It's like revision, ma'am.
Yeah, but the C5 is so difficult, na Bhargavi? Everything is new.
So that is water treatment technologies, right?
Yes, ma'am.
Yes, ma'am.
The first time we are studying that.
Okay.
Like we are familiar with the terms coagulation, filtration, and everything.
But then
going deep into the subject, it is new.
Yes, the technical new terms are also there.
Okay, shall I start?
Yes, ma'am, you can start now.
Already almost 2:35.
Yes, ma'am. 15 minutes we waited, ma'am. You start now.
Okay, no worries. Okay. So today topic is layers of atmosphere, right? Layers of atmosphere. So in the examination, they are asking climate system, climate layers, any, right? So you can write this topic totally, okay? So the atmosphere has how many layers? Anybody? Our atmosphere.
4, ma'am.
Our atmosphere has how many layers we have?
4, ma'am.
4, ma'am. Troposphere, stratosphere,
Ionosphere, exosphere,
mesosphere, ionosphere,
thermosphere.
exosphere.
Okay. So one is also there. So I will tell you. No worries. Okay. So before going into this main topic, we start from the Earth, right? So the Earth, you see here, Earth is the third planet from the where? Sun, right? Okay. The Sun. Yes. First, second, this third. So don't disturb, okay? Then next, you see the distance from the Sun, that is 149,600,000 kilometers, right? So that is 1 AU. What is the AU? That is called astronomical unit, right? Astronomical unit. So remember, so the distance from Earth to the Sun, that is called astronomical unit. So which is used to measure distance throughout the solar system, right? Entire solar system. So the Earth is only planet that is known to have an atmosphere containing, so you see free oxygen, oceans of liquid water on its surface, and of course life roughly 70%. You see here 70% of Earth's surface is covered by what?
Water.
Water. And most of it in the oceans, right? So, and 30%, remaining 30% of Earth's surface is
land.
Right? Yeah.
Land.
So, let's understand the layers of atmosphere. You see here, this, right? So, the layers and atmosphere, that is important role in making life that is possible on Earth by protecting our Earth from ultraviolet radiation from the Sun, right? So, the atmosphere of Earth is the layer of gases. Commonly, it is known as air. So that surrounds the planet of Earth and it is retained by Earth's gravity, right? So you see this picture. So this picture shows how temperature changes with higher in our atmosphere temperature profile that is pictured with this red line, right? This one. Okay, that is x-axis is temperature in degrees Celsius. Every 20 degrees from this is plus and this is minus, right? So minus 100 plus 20. So you see here. So here are 5 major layers. So this is 5th one, exosphere, right? So 4 are mainly, right? So the structure of the atmosphere depending upon these layers, right? So what criteria? Temperature variation criteria. So first of all, we learn about temperature variations of these 5 layers or 4 layers, right? So what you observe here is this temperature on one axis, right? and the baseline and this attitude. So what we see with this attitude and what happens to this temperature. So you look at this particular place, this troposphere, right? This one, sorry, this one. So what happens? The temperature actually goes from this positive to negative, right? So you like this, positive to negative, okay? So till this particular transition zone, that is tropopause, this tropopause. What is this? Anybody?
Between troposphere and stratosphere,
maybe it is the end of troposphere, tropopause.
Okay, right. Right? So, for some time, it remains constant. Here, you see this line. Here and here also, and here also. Wait, I will erase this one. Okay, right. Okay. So you see here as constant. So just wait. Okay, right. Okay. So it remains constant some time, right? So you see here, and you see here also, and you see here also. And then again starts rising when we go ahead in what? In attitude in stratosphere, right? So that is important. So then what we observe again, and it remains constant for some time, which is this stratopause also. So you see here also, and then next again here, right? So this is negative 80 degrees Celsius at the upper boundary of the mesosphere, right? So it goes to the minus segment, right? The next minus segment. So then in mesosphere, what happens? The mesopause. Mesopause. So it is the transition zone between mesosphere and thermosphere, right? So again here, sometimes it remains constant here. So that is 2 degrees Celsius. And then again it goes on increasing 82 degrees Celsius to 1200 or above, right? And further, when we go to this exosphere, so we find the differences here. So what we observe, so this is the sigma, like this, right? So what is the symbol of this? Like sigma, right? So this simple diagram, if we can remember, this looks like sigma symbol, right? So from the troposphere to the exosphere, the outer sphere. So how does this isotherm look like? sigma, right? So what happens here? There is a change in temperature across all these 5 layers with attitudinal some factors. So that is where the structuralization of the atmosphere. So that is important. So on the basis of this temperature, where we say these 5-layer structure are the stratified structure of the atmosphere, right? So you see here, there are 5 layers, right? So mainly 4. Extra is exosphere, right? So what are the 5? You see here, first one is, what is the first one? Tell me.
Troposphere, ma'am.
Troposphere, this one. The next.
Stratosphere, ma'am.
And the next, this is second.
Then mesosphere.
Third one. Okay.
Then thermosphere, ma'am.
Thermosphere. Okay.
Then exosphere, ma'am.
So these 4 are very important. Okay. This is, I think, maybe additional. Okay. So you see, first, one by one, I'll tell you. First one is troposphere, right? So tropos means change, right? It means change. So it is the first layer of the atmosphere from the Earth's surface. So it is also the one where we are living it, right? So this layer gets its name from the weather that is constantly changing and mixing up the some of the gases, right? So in this part of our atmosphere, so almost all weather conditions are here, only troposphere, right? So that is the importance for us takes place in the troposphere. And also storms, clouds, hurricanes, precipitation. So that is all in this troposphere, right? So this layer is the lowest and the closest to the Earth's surface, right? So this is the Earth. So this is the troposphere. So the troposphere is about 12 kilometers. You see here, 12 kilometers high, and the temperature at those altitudes is minus, how much? Minus 56 degrees. 56. Okay. 56.
Where, ma'am?
What is the temperature of the troposphere?
Troposphere. Okay. Minus 56 degree, ma'am.
56 degrees Celsius. Okay. So in this layer, temperature decreases with the height, going to height, right? So because atmosphere is predominantly heated by the surface. Okay. So now the troposphere is 12 kilometers deep, right? So, but that is not everywhere around the world. So the depth of the troposphere is around how much? 9 kilometers. Total 9 to 12. Total 12, right? So 9 is in the polar regions. Polar regions. And around 17 kilometers in the tropical regions. Okay. So this has to do with the fact that pressure decreases faster in cold air than warm air, right? So you remember that we said, let's assume these are 2 pressure surfaces. They are further apart if the air between them, right? So that is warm, then they are if the air between them, right? That is cold. And that's why troposphere is deeper in tropics than it is in the polar regions, right? So the air never static. in this layer. So it means in this layer, there is a lots of changes happening, right? So that's why it is also called changing sphere. Is that changing sphere? Changing sphere. Okay. So troposphere is a dynamic sphere where lots of changes are happening still, right? So in this layer where lots of atmospheric phenomena keeps happening also here, and all weather condition changes, it occurs in this particular layer. So most of the clouds, right? Clouds. So you see here white color, this one. So here also. So most of the clouds appear in this troposphere mainly. Because why clouds are appears in this troposphere? What is the reason? Anybody? So why not only stratosphere, mesosphere, thermosphere? Why it is only troposphere?
Because of the temperature, ma'am, they need to form, no, ma'am, because of the proper temperature.
Okay, that is also main reason. But because of 99%, but how much? 99% of water vapor. Water vapor in the atmosphere is found in the troposphere, right? So that is the main reason, right? So you see here, so in this layer, so the troposphere contains about 75% of all of air in the atmosphere and almost all of the water vapor which forms clouds and rains, right? So in this layer, air is made up of approximately 78% of nitrogen and 21% of oxygen and 1% other gases, right? Including argon, water vapor, and also carbon dioxide, right? So not water vapor, carbon dioxide, argons, and also something, right? So, and apart from that, we observe here what is happening. So the temperature decreases as you see in this table, right? So the temperature decrease at the rate of 1 degree Celsius for every 165 meters, 165 meters. What is that? 1 degree Celsius for every 165 meter temperatures decreasing, right? So, and so many people also write it into 6.5, right? 6.5 degrees Celsius for 1,000 meters. 1,000 meters. So that is kilometer. So it is an average value. So you can take either of them. That's okay. So that is also known as lapse, right? That lapse. A-P-S-E. Lapse rate. That is called lapse rate. Okay. So now remember there is a temperature decrease with the increase in altitude in troposphere. So this is also called the normal lapse. Normal, L-A-P-S-E, normal lapse rate or environmental lapse rate.
Can you explain again?
Is this? So temperature decrease with the increase in attitude. So this attitude. So in only troposphere.
Okay, ma'am.
Okay. So that is called normal lapse. N-O-R-M-A-L, normal, L-A-P-S-E, normal lapse rate or environmental lapse rate. That is called E-L-R. Okay. So,
okay, ma'am.
Okay, right. So this is the troposphere. Then next, stratosphere, second layer, right? So strato. So strat, S-T-A-R-T, up to here. Strat means layer. So this layer of our atmosphere has its own sets of layers. So the boundary between the stratosphere and the troposphere is called, what is that?
Tropopause.
Right, this one. You see here. Okay. It is the region where airplanes are flying. So because this less turbulent layer provides a smoother ride, right? So yes, the streams flows near the border between the troposphere and the stratosphere. So that is tropopause, right? So the lower boundary of the stratosphere is called the tropopause. So the stratosphere layer extends from the tropopause to about how much? 50 kilometers. This 50, okay? 50 kilometers are 31 miles. 31 miles above the Earth's surface, right? So from troposphere, from this troposphere, how much? So this is the, from the surface of the Earth, 50 kilometers, right? So troposphere is 12 kilometers. So from troposphere up to stratosphere, how many kilometers? Not from the Earth surface, from the troposphere.
What, ma'am?
My, hello?
50 kilometers.
Durgesh, ardhamainda?
Ma'am, your voice is getting broken.
Okay, sorry. It is clear?
Yes, ma'am.
Okay.
Yeah, ma'am.
So you listen carefully. So stratosphere. So this layer extends from the tropopause about 50 kilometers, right? So this layer contains a thin layer of ozone molecules which forms a protective layer and absorbs harmful ultraviolet radiation from the sun. So this layer is very dry as it contains little water vapor, right? Water vapor. So that is very little bit, right? So now here temperatures does not decrease with the height. Instead, temperature is first fairly constant. And then it is actually increasing with the highest temperature tends to, as we can see, overall increasing with the height temperature tends to, as we can see, overall increase with the height in the stratosphere, right?
Yes, ma'am.
So because of ozone that absorb ultraviolet light or ultraviolet rays and protects. So all us living creatures from harmful impacts of ultraviolet radiation or ultraviolet light. So the highest concentration of ozone is between, where is ozone?
35 kilometers.
15 to 35 kilometers above the
Tropopause.
right. Okay. So this is important. 15 to 35 kilometers, right? So the stratosphere actually gets warmer the higher the trend of rising temperature with altitude. That means the air in the stratosphere lacks the turbulence and updraft of the troposphere beneath. So the high altitude weather balloons flying into the stratosphere for monitoring atmospheric conditions and climate researchers. So now it is interesting to note that while all light aircraft flies in this troposphere, like those that spray some chemicals to kill mosquitoes, and commercial passenger jets fly, right? So jets fly and weather balloons. So these reach their maximum operational altitude within this stratospheres.
Ma'am, it's in troposphere, no?
No, that is jet flies.
Okay, okay, ma'am.
Right. So, and also some of the military airplanes, right? So military airplanes can reach even higher altitudes. For example, that is S-Star. That is the name S-Star-71 Blackbird flyer, right? Blackbird flyer. So, and 25.9 kilometers in the stratosphere. So this can fly at 25.9 kilometers. And also some of the Russian Sukhoi Su-57 also at the level of 20.1 or 20 kilometers above the surface, right? People are understanding this one?
Yes, ma'am.
Okay. So,
cannot remember the names, ma'am, which you just said.
Okay, that is SR-71. You can write here SR-71 Blackbird, BLACKBIRD Blackbird.
Okay. This is a what, ma'am? Normal aeroplane.
Yes. Name of this. Name only. This is the name, right?
Yeah, ma'am. Okay.
Then next, some of the Russian Sukhoi, S-U-K-H-O-I.
K-H-O?
S-U-K-H-O-I. That is Su-57. That is called Su-57. So Blackbird is SR-71. Sukhoi is Su-57. Okay. So this is how much kilometers? 20 kilometers above the surface, right? Sukhoi. And SR-71 Blackbird at the level of 25.9 kilometers. Okay, Nubia?
25.9, no, ma'am?
25.9.
Okay, ma'am.
This is
above the tropopause, no, ma'am?
No, above the surface.
Above the surface of where, ma'am?
Earth.
Earth, acha, okay, Earth. In the troposphere only, ma'am.
Yeah,
starting of stratosphere.
Troposphere, right. Okay.
Yes, ma'am.
So this layer provides some advantages for flights. Why there is an advantages to fly in this layer? Because the stormy weather is not there. So the stormy weather actually ends at tropopause only. So tropopause, right? So there is this layer where there is an advantages of flying for these flights, right?
So, ma'am, all these should be in troposphere and not in stratosphere, no, ma'am?
No, middle of here. Okay.
Okay, above tropopause.
Yeah. Okay. So the next, the ozone layer is found in this layer only, right?
Okay, ma'am.
See here. Huh?
Yes, ma'am.
So that is 15 to 35 kilometers, right? So now, so the infamous ozone layer that is found within the stratosphere, right? So in the atmosphere, ozone exists in two forms. So two forms. What are the two forms? First one is good ozone. Second one is bad ozone. Okay. So bad ozone formed in the atmosphere, that is troposphere. So that this harms to plants and also animals. That is bad ozone, right? So good ozone. What is the good?
Protects us from the ultraviolet rays, ma'am.
Yeah. So this is protect us, right? Against dangerous ultraviolet light from the sun. So good ozone is found in the upper part of the atmosphere, that is the stratosphere, and it acts as a shield absorbing ultraviolet radiation from the sun, right? So
Yes.
the thickness of the ozone in column of air from the grounds to the top of the atmosphere, that is measured in terms of DU. That means Dobson unit. Dobson.
Thickness of air, ma'am.
No, ozone.
Acha, thickness of ozone.
Ozone, okay? Dobson units. You see here, I already write here. This one.
Yes, ma'am.
Units, okay? Measure in terms of ozone is thickness ozone. Okay?
Okay, ma'am.
Right? Then next. Mesosphere. So, which number is this layer?
Third, ma'am.
Yes, right. Third one. I'll have you alert or not. That's why I'm asking. Okay.
Yes, ma'am.
Okay. Meso. It means, meso means anybody?
Meso.
So means middle.
Okay, middle.
Okay. It means,
Yes,
so this layer is located above the stratosphere and what?
And stratopause.
Above the stratosphere and below the?
Below the
You see?
thermosphere.
Yes, right. Okay. So you can write this layer is located above the stratosphere and below the thermosphere.
Thermosphere.
Called mesosphere, right? So it is the coolest layer of the entire atmosphere. Remember this one, right? Coolest layer. So it is the third layer in our atmosphere, and its variation is from 50 kilometers to 85 kilometers
Yes, ma'am.
above our planet. So by 80 kilometers, it reaches up to about how much? Minus temperature, minus 90 degrees Celsius temperature.
Oh my God.
So about 80 kilometers, right? It becomes now minus. So that is important, right? So that's why this layer is called coldest layer.
It starts from which temperature, ma'am? From stratosphere? Stratosphere.
Before sphere, what is that before sphere?
Stratosphere, no, ma'am.
Right. So this is from 50.
50.
50.
50 degrees.
Right.
Minus 50 degree.
Okay. So just 1 minute. So the air in the atmosphere is far too thin, right? So
yes,
air pressure at the bottom of the layer is well below how much? 1%, right? 1% of the at sea level and continues dropping as you go higher, right? So most of the meteors, so you see here, these meteors.
Yes, ma'am.
So these meteors fall and burn up in this atmospheric layer. Only.
Because of the cold, the heat
right.
reduces and disappears, ma'am.
Okay. Transition boundary which separates the mesosphere from the stratosphere. So that is called.
What did you ask, ma'am?
boundary which separates the mesosphere from the stratosphere.
Stratopause.
Yes, stratopause, right? So here tropopause and here stratopause, right? So in the mesosphere, air molecules, that is to absorb incoming electromagnetic radiation from the sun, right? So this is the mesosphere, okay? Then next, you see here, this is the meteors, so 50 to 85 kilometers, right? So then,
Yes,
this is thin air pressure layer. Thermosphere. This is fourth one, right?
yes, ma'am.
Fourth one. So now thermo. T-H-E-R-M-O. Thermo means?
Thermal, ma'am.
Thermo. This is thermosphere. Thermo means? Anybody?
Heat, ma'am. Heat.
Right, very good. So that means heat. So this layer is, it has extremely high temperatures and located above the mesosphere, right?
Yes, ma'am.
And below the
exosphere.
Right. So the boundary between the mesosphere and the thermosphere, atmospheric regions, that is called mesopause, right? Mesopause, this one.
Yes, ma'am.
This one. So it is the coldest part of the Earth atmosphere also. So the thermosphere extends from the mesopause to, remember this one, extends from the mesopause to 700 kilometers. Okay? 700 kilometers. It means 440 miles above the surface of the Earth.
Okay, ma'am.
Okay. So the thermosphere is the thickest layer in the atmosphere. So only the lightest gases. Oh, so what are the lightest gases? Mostly oxygen, helium, and
helium.
so these gases are right. These gases are in this found in this layer only, right? So the thermosphere absorbs high energy X-rays and ultraviolet radiation from the sun and atoms, turning them into ions with a positive charge, right? So the temperature of the thermosphere varies between night and day and between the seasons as do the number of the ions and electrons which are present in it, right? So I told in next unit, I think what is UVA and UVB and UVC, right? So that is another topic, okay?
Okay, ma'am.
So you see here, so the ionosphere reflects and absorbs radio waves, allows us to receive shorter wave radio broadcast from the other parts of the world, right? This one. Okay. So the temperatures in the upper thermosphere can range from about 500 degrees Celsius to 2000 degrees Celsius. 500 means 932 degrees Fahrenheit and 3632 degrees Fahrenheit. 2000 means. Okay.
Ma'am, if we write in any one unit, that's fine, no? If we write in centigrade only.
There are, yeah, you can write this, or you can write some of the 932 degree Fahrenheit or 500 degrees Celsius. You can write it. Okay?
Okay, ma'am.
So ionosphere, what is the ionosphere? Ionosphere.
Ions.
Charged ions are present in that layer.
Charged ions.
Here, right?
Negative and positive.
Atmosphere has another further bifurcation where we say this is called ionosphere here. Okay? This one. So it has electrically charged particles ionized by cosmic and solar radiations.
Ma'am, can you repeat?
Electrically charged particles.
Okay.
Ionized by cosmic and solar radiations, right? So the ionosphere ions are there. The charged particles are plus, are and also minus, right? Here. So this is plus and this is minus. So basically these charged particles are the important factors. So which are called ionosphere in the lower thermosphere. So which actually this lead to this radio waves emissions. This one. Okay.
Okay.
Those are helps us, right? So where charged particles in the ionosphere that is reflects back and it leads to the radio wave communication. It helps us in that, right? So the temperature increases with height in this layer, right? Then next you see here, this is thermosphere, right? So you see here aurora. What is this aurora?
Aurora borealis, ma'am.
I will tell you. Aurora and satellites. So aurora and satellites mostly occurs in this layer. You see here satellites.
Yes, ma'am.
So aurora. Aurora is a natural light display in the sky. Okay. So particularly in the high latitude regions. So that is caused by the collision of energetic charged particles with atoms in the high altitude atmosphere. So this is where these charged particles are ionization happens, and that is where the flash of radiations in different kinds of color streams, right?
Yes,
and the satellites for communication have been placed in this layer. So that we see here, right? So that is the important point. So you
so ma'am, from 700 kilometers, we are able to view it in the troposphere, ma'am.
Yeah.
That is so bright.
Yeah.
Okay.
So this is the thermosphere. And lastly, exosphere.
Exosphere.
Okay. So those four are very important layers, right? Yes. So next, exo. Exo means?
Outside.
Right. Very good. Exo means outside. So the exosphere represents the outermost. So that's called outer.
Outermost, okay.
Right. So outermost layer of the Earth atmosphere. Right. That is the exosphere. So it extends from the top of the thermosphere and about 700 kilometers. This one, right?
Yes, ma'am.
To about 10,000 kilometers. It means 6,200 miles. 6,200 miles or 33 million feet, right? 33.
So this should be the thickest layer, no ma'am? But we don't count it, no ma'am?
Yeah, right. Right? So where it merges into the solar wind above the Earth surface. Remember this, Earth surface. Okay? So this layer is mainly composed of extremely low densities of hydrogen and also helium and several heavier molecules including in this layer, right? So this is the exosphere and outermost of the layer, right? So that's why name is exosphere.
Heavier molecules and helium is the lightest, no ma'am? How can it be present?
Not helium, hydrogen,
okay.
Right?
any other heavier one.
Yeah, right. Okay. So in this layer, the ozone where atoms and molecules escapes into the space is mentioned as the exosphere. So the International Space Station, you see here.
Yes, ma'am.
So this station orbit is also in this exosphere, right? So these are the atmospheric layers. Those are 5 types, right? So you can write these 5 layers in your examination. You can explain one by one, okay? So sometimes they are asking only stratosphere.
Yes, ma'am.
Okay, so you can write only the like this stratosphere.
Yes.
And now,
ma'am, satellites are present below space stations.
Yeah, below space station.
Okay, in the thermosphere.
So that's why you see here, you observe here. So in tropopause, aeroplanes are flying.
Yes, ma'am.
And jet flies, and also meteors here, and
satellites
in thermosphere, and space station is out of these layers.
Yes, ma'am.
Right?
Yes, ma'am.
So that's why I put this image in your slides, so you can easily understand this figure, right?
Yes, ma'am.
Now, so ozone creation and ozone destruction. So the concentration of ozone in stratosphere is thinnest in the tropics. It means around the equator, right? Equator line. So, and denser towards the poles. So the amount of ozone above a point on the Earth's surface that is measured in, what is that? Dobson units.
Dobson unit, yes, ma'am.
Right?
Yes, ma'am.
Typically about 260 Dobson units of ozone is present near the tropics and elsewhere. So there are large seasonal fluctuations. So it is a higher concentration occurs in lower altitude around the poles, right? And in higher altitude above the equator, between how much? 18 kilometers to 26 kilometers. So it is created in the tropical regions. But when ultraviolet light strikes the stratosphere and splitting oxygen molecule to form ozone, okay, O3.
Yes, ma'am.
Okay. Go.
Ma'am, what is the DU in near poles, ma'am? No, ma'am. You said 260 DU present near tropics, no, ma'am. So near poles, what are the DU units?
Tropics. That is, I can't understand.
No, ma'am. You said 260 DU units near the tropics, no, ma'am. So near the poles, what are the DU units?
I think maybe 200.
Ma'am, it should be high, no, ma'am.
High. Sorry, this is low now. Actually, I don't know about that exactly units.
Okay. Maybe it should be at least more than double.
Double, right. I think maybe 500 to 600.
Okay, ma'am.
Okay. Right. So you see here now, natural ozone cycle. This is the natural ozone cycle. So when we say natural ozone cycle, and what happens here? So oxygen, O2, which is oxygen, right? And it reacts with the ultraviolet light. So that is ultraviolet radiation. It breaks into the oxygen plus oxygen. O. So that is separated O and separated O, right? That's
yes.
2 plus ultraviolet, that is O plus O. So now this one separate oxygen actually attaches itself to the oxygen O2 here, right? So, and it becomes O3. So, which is what we commonly call as
ozone.
Right? So, that's where this ultraviolet is important here, right? So, O plus O equal O3. So, O3 plus ultraviolet, ozone plus ultraviolet again give you one O and one O2. So, this is a simple chemical reaction, right?
It's a cycle, no, ma'am?
Yes?
It is a cycle. It's like cycle.
Yeah, right. Okay. So, yes. This is what you observe is the role of this ultraviolet rays here, right?
Yes, ma'am.
So, we have 3 cycles. So this is ozone is creation, right? The next destruction. In this destruction, we have 3 cycles, right? So first cycle. Okay. So first, stratospheric ozone is destroyed by reactions involving reactive halogen gases, which are produced in the chemical conversion of halogen sources gases, right? So the most reactive of these gases, what are the gases? Chlorine monoxide. Chlorine
monoxide.
Yeah, right. CHLORINE. Chlorine monoxide. CLO. And bromine monoxide. Bromine monoxide. Monoxide. That is BRO. Right? BRO. Right? And also chlorine and bromine atoms, right? Chlorine and bromine atoms. So these gases participate in 3 principal reaction cycles that destroy ozone, right? So you see first cycle. So you see here the ozone destruction cycle this cycle is made up of 2 basic reactions. What is that? Chlorine plus ozone, right? And also CLO. What is that? CLO reaction, right? CLO plus O. These 2 reactions, right? So the net result of cycle 1, that is to convert ozone, 1 ozone molecule and 1 oxygen atom into 2 oxygen molecules, right? So in each cycle, okay? So the chlorine acts as a catalyst because ma'am, I will just go to okay. So catalyst, because CLO and Cl reactant, these are reformed, right? So in this way, so 1 chlorine atom participates in many cycles, right? So destroying many ozone molecules. Remember this one, many ozone molecules. So for typical stratospheric conditions at middle or low latitude, a single chlorine atom can destroy how much? Thousands of ozone molecules before it happens to react with another gas and breaking catalytic cycle. Okay. So during the total time of its stay in the stratosphere, the chlorine atom can thus destroy many thousands of ozone molecules. Remember this one, right? So this is the first cycle, and you see this is one, second cycle and third cycle. Okay. Okay, right. So in cycle 2 and 3, the abundance of ClO is greatly increased in polar regions, right? So during late winter and early spring, that is relative to other season, right? So as a result of these reactions on the surfaces of polar stratospheric clouds, right? And cycle 2 and cycle 3, it becomes the dominant reaction mechanism for polar ozone loss because the high abundances of ClO and the relatively low abundance of atomic oxygen, right? Atomic oxygen. And then in the cycle, it begins with the self-reaction of this ClO, right? Self-reaction of ClO. ClO plus ClO, that is called ClO2. Okay? So,
chlorine dioxide, ma'am.
Right, chlorine dioxide. Okay? The next cycle 3, which begins with the reaction of ClO and Br or BrCl also, right? BrCl. Bromine chloride, right? So the net result of both these cycles is to destroy what is the 2 ozone molecules, right? And get 3 oxygen molecules, O3, right? Ozone means O3 molecule. So this cycle 2 and 3, this account for most of the ozone loss absorbed in the stratosphere over the Arctic, right?
Yes,
Arctic and Antarctic. Okay, Antarctic regions in the late winter or early spring season.
Ma'am,
Right?
that is why the ozone depletion layer, the most is in the Antarctica, no ma'am?
Right. So that's why that's called Antarctica ozone hole. Right?
Okay,
so that's the reason. Why is Antarctica ozone hole is important? So this is the reason, right? So next, and also sunlight. Sunlight is required to complete and maintain these reaction cycles, right? So in cycle 1, it requires, what is that? Ultraviolet, right? Ultraviolet radiation. That is strong enough to break apart molecular oxygen into atomic oxygen, right? So in this, most important in the stratosphere at altitude about 30, right? 30 kilometers, where solar ultraviolet C, UVC radiation, right? So I told.
What is C, ma'am?
I will told another PPT. So this is the biggest topic. Okay.
Okay, ma'am.
Ultraviolet radiation, A, B, C, right?
Okay, ma'am.
So this is the ozone creation and ozone destruction. So they are asking in your examination 5 marks question. So write about the ozone creation. So you can write only this thing, 5 marks.
Okay.
Or destruction. So only they are asking many times this one only, ozone creation cycle. Okay. This is called ozone cycle. Okay?
Yes, ma'am.
Okay, so now this topic is over. Okay. Then almost 3:35, right?
Yes, ma'am. This was a very interesting topic.
Yeah. Okay. So
Ma'am, please share the PPT, no?
Definitely. Yesterday also I will share the.
Yes, ma'am. Yes, ma'am.
Okay, no worry. So can
It
I
was very short
class
and
after
clear, ma'am.
half an hour?
Ma'am, this PPT was very short and clear.
Yeah, okay, thank you. I put in these images, right? Yeah. So you can easily understand, right?
Yes, ma'am.
Okay. Right. So can I take another more class after half an hour?
Yes, ma'am, you can continue only, then we'll get done early.
So if you're interested, tell me, then it's not okay.
Ma'am, can you continue now only, then we can get done early, then we have to come again.
Okay, wait.
If it's fine with other students also.
But not this username and passcode. So I will share another username passcode. Okay?
Okay, ma'am.
Right?
Okay, ma'am, you can continue now only.
Okay.